And start things off here. First off, I'd like to thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fisher Technic Education Division over here at Studica. And of course, as you know, today I'm going to provide you with an overview of Fisher Technic's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in something like CTE training, if you're a college professor or an industrial trainer teaching programming skills required in manufacturing, or if you're a company looking for ways to demonstrate your software-based solutions, or even just someone who's looking for a way to make IoT-related concepts easier to understand to employees or customers, in any of these cases, I really do think this presentation is going to offer some important options for you to consider. And just bear with me a second here. Minor glitch. Okay, now we're in better shape. All right. So we're going to start off by considering the skills gap. Now, if you've attended any of our other Fisher Technic education webinars, you've probably heard me discuss the importance of STEM education. Of course, STEM is the acronym that stands for science, technology, engineering, and mathematics. And it really should go without saying at this point that STEM education has probably been the most hotly discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is really in large part to help the best prepare them to take their place in the modern workforce. Now, not so long ago, when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have backgrounds in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions that we're going to be looking at in this presentation, let's stop for a minute and consider that last skill area I just touched upon, that of being a PLC programmer. Now, first off, in case you're not familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. And essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes that are typically found in an industrial setting. These are going to be things like an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. So to get a clear idea of just how highly prized these kind of programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer's salary in the United States is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I worked on the original version of this webinar, and this was back in 2020, I took a look at the list of current job openings for PLC programmers that were listed on nuvu.com, and at the time, the list showed 15 positions being advertised, all showing salaries of over $75,000 per year, and two of which even listed salaries of $195,000 per year for PLC programmers. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as this quote unquote workforce of tomorrow is getting their training, more and more manufacturing companies who face the urgent need right now are enrolling their workers into private training schools offering programs focused on just this. So how long does it take to learn these skills? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of study. Of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on the screen now, as well as really learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are other options available, things like high school CTE programs, as I touched upon, adult continuing ed programs, vocational training, technical training in trade schools, and again, employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, and this is whether you're in the university or the vocational school setting or whatever kind of classroom you're in, is how do you go about and teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations that had their moment, but now it's like everybody's seen it, and instead make it more realistic and hands-on? But before we go more into that, there are other areas of focus beyond just programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be, again, a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as kind of abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer that's looking for ways to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's even a company looking for engaging ways to demonstrate their services or solutions in a public setting, such as a trade show. In each of these cases, and there are more, there is a need for finding a solution that is, again, engaging, which can effectively mimic and simulate real-world automated systems. And that's going to bring us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, in appearance and function, various automated robotic machines and systems commonly used in commercial manufacturing. Now, before we begin to look at each of the models, I'm going to provide you with just a little bit of background on what exactly fischertechnik is all about. Fischertechnik, as a company, has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. And what makes the system unique is that unlike other popular construction systems where the components are designed to simply stack, with the fischertechnik system, it was created with more of an engineering mindset. And what I mean by that is that the core building block in the fischertechnik system, such as you see in the diagram on the screen right now, is designed to enable attachment from all 6 sides. And because of this, it all allows for almost limitless design possibilities. Now, many of the parts that are used in the system are designed to slide together and lock in place using the tongue and groove assembly method. Again, I would refer you to the diagram on the screen. And the hundreds of different parts available will also help you to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949, and he is also credited as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, still employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, and it's whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by fischertechnik for the education sector are what we would call subject-specific sets. And by this, I mean they focus on different STEM-related areas, things like mechanics, pneumatics, robotics, or renewable energy. Now, in most of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then perform various experiments, which allows them to explore and understand different aspects of that particular subject. There are also sets that are put together that can be used for a classroom program. There have been curriculum-based programs that have been put out over the years, and there have also been project-based learning programs using fischertechnik. And with the project-based system, it's where the students have to do a lot of trial and error work, work in teams, and basically devise their own solutions to different problems, usually built around mechanics and automation, things of that nature. So that's kind of what the fischertechnik education line is usually about. Now, the line of fischertechnik simulation solutions, which of course are the focus of today's presentation, are something a lot different. This line consists not of kits, but this is a series of pre-assembled small-scale models which are designed to replicate in both appearance and function various automated robotic machines and systems. And the types of models you're going to find in the fischertechnik simulation line include things like conveyor belts, punching machines, three-axis pick-and-place robotics, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models, which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. Now, this model consists of 4 individual workstations, in this case, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, all combined to work together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, I'm going to briefly outline some of the advantages of using fischertechnik solutions. Now, I apologize in advance for any of the points that I've touched on before, but I think in each case, it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models are once again designed to realistically replicate, in both appearance and in function, common automated systems, things such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of these models is available in a 24-volt version, which is designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you prefer Siemens controllers, or if you use controllers from manufacturers such as Honeywell, Mitsubishi, General Electric. Of course, we could go on and on. In any case, you can control these 24-volt simulation models with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the versions listed on the screen right now. Now, please note that with the 24-volt versions, no PLC is included, with one exception, which we'll talk about at the very end. But in most of these cases, no PLC is included. Any of the wiring from the model itself to where the PLC plugs in, that would be something that the end user would have to take care of themselves. Any programming guidance, power supplies, what have you, are the responsibility of the end user. So in most cases, unless I noted otherwise, we're talking about a model that you're going to need to incorporate with the wiring, the PLC, the programming on your end. If you're using a trainer or what have you, you could incorporate it with that as well. Now, in addition, for non-industrial users and for educators who aren't versed in or familiar with using PLCs or getting into PLC programming, there are a select few models which are available in 9-volt variations. Now, in the case of these 9-volt variations, they do ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controllers, and some of the models are being upgraded to the new Robotics TXT 4.0 controllers. And each of these controllers in these cases comes pre-programmed using fischertechnik's own proprietary RoboPro graphic programming software. Now, in the case of the 9-volt models, which we'll mention, the only additional component that's going to be required on the end user's part is going to be purchasing a 9-volt power adapter, power supply, and some models may require a few of these. I will mention in either case as we're talking about each of the models. Otherwise, essentially, the 9-volt versions should be pretty much ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, which is, of course, known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. Now, in the case of this model, it's designed to be both controlled and monitored from a special web-based dashboard. Now, we're, of course, going to discuss and look at this in more detail a little bit later in this presentation. And finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look at any of the other hardware-based industrial simulation options in the marketplace, you'll probably notice that the entry point for many of the products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are more often available just a fraction of that price, as well as being, again, compact, realistic, and high-quality learning and demonstration tools. So on that note, we're going to get started with the overview. Give me a second here. I'm going to get a drink of water because I've been talking a lot. And I will mention here, before I get to the next slide and we start on looking at the models, please, if you have any questions or what have you can feel free to type them in the question and answer window that you'll find on the Zoom toolbar. There's a chat window as well. You can ask questions there. Just know that I will most likely not address those questions until the end of the webinar, just because there's a certain flow to things. So I'm probably not going to jump back and forth between the chat windows and the Q&A windows and what have you. So if anything does come up, just type it in there and know that I will get to it at the end, and we will eventually talk about pricing as well. So no worries there. So let's get started. First off, we're going to look at the vacuum gripper robot, as you see in the picture here. Got a little video we're going to share. Now, as you're going to see in this video, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. And the model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt version of this model, as well as all of the first 5 24-volt models that we're going to be looking at today, each have a relay board for motor polarity reversal, and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, this 24-volt version of the model, as well as all of the 24-volt versions we're going to be looking at in this first part of this presentation, are going to require you to provide the PLC and the programming and do any additional wiring. I will also mention that for this and for all the other models that we're going to look at today, the specs are also detailed in the product listings found on the Studica website and the fischertechnik.biz website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation if you're so interested. So we'll just let this play out for a second here. And I will mention that as I didn't touch upon 9-volt versions, this one is not available in the 9-volt version. The next model we're looking at, which will have a 9-volt version, is the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 phototransistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will mention that this particular model ends up being a real favorite among educators I've spoken with who are involved in programming. And the reason for that is because it gives you so much to work with in regards to all of the programming of the movement of the picker arm, the picker mechanism, the precision that has to be used to insert and remove the different work pieces from the storage bins. And because of this, because of all the very specialized coding that has to be done for each of those steps, again, it's really beneficial for, any of these classes where you're working on the programming. The dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a total weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal in both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you will need to provide the PLC in the programming. There is, as I mentioned, a 9-volt version that's available at this time, which again is pre-wired to a pre-programmed robotics TXT controller, and it does require one power adapter, which we do sell. The next model in the line that we're going to be looking at is the multi-processing station with oven. The model you're going to see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, the standard version of the model and the 24-volt version for use with PLC of your choice, once again, has a relay board for motor polarity reversal in both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And there is a limited edition 9-volt version. In this case, it's connected to 2 robotics TXT controllers. And because of that, the 9-volt version would require 2 power adapters, not just 1. Let this play for just a second. Sometimes I get a little ahead of the videos, and sometimes the videos get a little ahead of me. And there we go. And she says it's cool. The next one we're looking at is the sorting line with color detection. Let me just do one thing here. Okay. Now, this simulation features a system for detecting workpieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide the PLC in the program. And the limited edition 9-volt version, in this case, we do have a 9-volt version as well, again comes pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is required for that. We'll let this play for just a second. Oops. And we'll just let this finish through. And there we go. The next model we're going to look at is the factory simulation, which combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection into one self-contained material cycle. And the cycle works like this. What you're going to see is that work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. Now, after the workpiece has been processed by this machine, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I'm not going to belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one work cycle, it has a much larger footprint, in this case approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. A few things to note. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt variation as well. In the case of the 9-volt version, it's wired to 5 robotics TXT controllers, and as such, it's going to require 3 of the power adapters. As always, the 24-volt version will require the end user to provide the PLC, the programming, and any other hardware required. Again, each station of the 24-volt version has a relay board for motor polarity reversal, the multi-pin connectors, as I touched on before, and again, PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations, which we just looked at, who will need to transport the model or protect it when not in use. Now, in this case, the travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of about 53 pounds. Now, please note that even when you use the travel case, these models will still need to be shipped flat, and if you're shipping them to a different location, you will still always want to ship them on a pallet just to protect them. Moving right along, we're going to look at the conveyor belt. And as you see, it's a very basic conveyor belt. It has a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you may desire. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions for the model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, in this case 26 pins, with a 2.54 millimeter grid, as shown here. And for a limited time, we also offer a 9-volt version pre-wired to the robotics TXT controller, as shown here. And in this case, 1 power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine component. This features essentially the same conveyor that we just looked at, except this time the machining station is built onto it. The components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches. It has a weight of about 3.5 pounds. Again, it's available in a standard 24-volt variation with the 26-pin connector and the 2.54 millimeter grid is shown here. And we also have for a limited time, we are offering a 9-volt version wired to the robotics TXT controller, and 120-volt power adapter is required with that. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station, and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the standard 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with a PLC, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controller, and again requiring 1 power adapter. Next is a variation on the idea of a pick-and-place robot, the 3D, or as it's also known, 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees, Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And again, this comes in either a 24-volt version with a 26-pin connector and 2.54 millimeter grid, again designed for use with the PLC and programming of your choice, or in a 9-volt version, which in this case is not a limited availability model, but is a standard model. And again, it comes pre-wired to the pre-programmed robotics TXT controller and requiring 1 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next group of simulation models we're looking at is going to focus specifically on the area of IoT and is designed for demonstrating and teaching about cloud-based monitoring and control. And these models go by the name of Training Factory Industry 4.0, and they are available both in 24-volt version for use with PLC and 9-volt variations for classroom and demonstration purposes. Now, this model has been designed to help address how the recent changes in industrial production driven by digitization have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they become implemented on a larger scale. Now, as this video showcasing the 24-volt version does provide a nicely narrated overview of all the aspects of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The Fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
So giving a little bit of a summary, the following topics can be addressed with the Fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, this model incorporates many features not found in the models we looked at previously, besides most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. And the use of NFC chips in each individual workpiece, each of which again has a unique identification number, enabling the position of each piece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the networked TXT controllers to communicate with one another. Now, as there are two variations of this model, let me talk about what makes them different aside from the voltage requirements. And we're going to begin by focusing on the 24-volt version and what makes it unique. First off, it is a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one fischertechnik robotics TXT controller. In this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED, and this allows for the option to not only present and use data on a dashboard in the fischertechnik cloud, but also to display data and calibrate stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC, and these, of course, all ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, pulse width modulation, and they also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Unlike any of the previous 24-volt models we've discussed, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. Now, in this case, the sample program is in structured text format, and it was created to be used with a Siemens S7-1500 PLC, and this is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And to enable you to do this, there is also source code needed for this that's also available for free download from GitHub. Now, as with all the other 24-volt models we looked at today, the Training Factory Industry 4.0 has the relay board for motor polarity reversal and both a multi-pin connector. Again, this is the 34-pin with grid of 2.54 millimeter variation, along with PCB terminals with push-in connections for all inputs and outputs. And again, all of this information and much more can be found in the 152-page PDF manual, which can be downloaded from the fischertechnik website, or if you need it from me directly, I'll be happy to send that to you. I will provide information at the end of this presentation. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt variations we looked at today, in this case, the programming is not using RoboPro, but instead using C, C++. Again, in the case of the 9-volt version, all the programming is preloaded so that essentially once the connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation that is available specifically for this model. Again, also available on the fischertechnik website or from us directly. Once you've done the connections and got connected to the web, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 power adapters. Of course, it goes without saying that any of these Industry 4.0 versions will require the ability to access the internet. And of course, they're going to require a tablet or a device for accessing a cloud-based dashboard, so that you have to have on your own. Dimensions for these factory models are approximately 39 by 31 by 16 inches. They have a weight of approximately 51 to 53 pounds each. And as with the 2 factory simulation models, which we looked at previously, we do recommend the optional travel and storage case to help protect your model during transport or storage. And that is the Training Factory Industry 4.0 model, now available in both 9-volt and 24-volt variations. Of course, the next question would be about the pricing on these models. So we're going to take a quick review of each option that I've discussed along with the pricing. First off, on the vacuum gripper robot, only available in the 24-volt variation, it is $1,129.95 each. The automated high bay warehouse is available in both versions right now. The 24-volt version is $1,369.95. The 9-volt version is $1,318.95. The multi-processing station with oven in the 24-volt version requiring PLC is $1,199.95. The 9-volt version is $1,474.95. The sorting line with color detection in the 24-volt version is $1,049.95. In the 9-volt version is $1,128.95. The factory simulation in the 24-volt version for use with PLC, $4,829.95 is your cost. If you would prefer the 9-volt version with the TXT controllers connected, that is $5,239. The conveyor belt in the 24-volt version is $324.95. In the 9-volt version with the TXT controller is $518.95. The punching machine with conveyor belt in the 24-volt variation is $419.95 for use with PLC. 9-volt version with the TXT controller is $599.95. The 3D 3-axis robot in the 24-volt version is $999.95, and in the 9-volt version, $1,369.95. The index line with 2 machining stations in the 24-volt version is $1,129.95, and in the 9-volt version is $1,394.95. And the Training Factory Industry 4.0 models focused on IoT and cloud-based control in the 24-volt version, again, with the sample program that you get access to. That's $8,999.95, does require the PLC, the additional wiring, etc. The 9-volt version is available with the TXT controllers, and that is $9,024.95. Now, as I mentioned before, there was going to be a variation with PLC, and we're going to talk about these now. There are new Training Factory Industry 4.0 models. These are only the 24-volt version. There is one that includes the PLC connector, and by this I mean all of the wiring that has to go on from the model itself to the PLC connection board has been done for you. That variation, and that you're going to still have to provide the PLC for that, of course. That variation is $12,079.95. Or if you want a version that includes all of that wiring, includes the PLC, includes the programming, of course, includes the power supply, that version is available if you're ordering for an academic institution. It is $18,499.95. If this is for commercial private use, it is $20,124.95. And again, that includes the Siemens PLC S7 1500. Other items that I've touched on several times throughout the presentation, the 120-volt power adapters for use with the 9-volt models, and also for the Training Factory Industry 4.0, you need one of those for the 24 volts to help to power up the TXT controllers that you use there. Those are $12.99 each. The travel and storage case, which can be used for all of the factory simulation and Training Factory Industry 4.0 models we looked at, the 2 I just mentioned, the 2 we saw in the video with the narration, and the 2 we saw earlier, that travel case is $1,524.95 per unit. Breaking news, there is a new model that is called Quality Control with AI. And this is rather interesting. What this allows you to do is basically to begin to introduce the AI component. In this case, the model has as you can see, it's a conveyor line that has sorting bins. But in this case, what the model does is it sorts the parts based on not only what they should be, i.e. the color and the markings that they should have, but also it sorts out what are called quote unquote defective parts, pieces that are, let's say, not labeled properly, that might have a crack in them, what have you. What it does is it's set up so that a camera takes a picture of each model as it's passing through the conveyor, and it's able to judge, using the AI component, whether it is a good piece or a bad piece. And then it's, of course, sorted into each of these bins. Run through some of the slides here. This model is currently only available in a 9-volt variation. We do expect to have the 24-volt variation available in the next month or two, so we're just waiting for the news on that. As you can see. So currently, the 9-volt variation of this is available. This, again, comes pre-wired to the Robotics TXT 4.0 controller, pre-programmed. That version is $2,089.95. And again, the 24-volt version is expected this fall. So we're going to have more information on that soon. Now, normally I would open up the floor to any questions, but as I see, we are having some technical difficulties with some of that. So I am just going to jump along. And if you have questions, or if you'd like to take the next step, let's say you want to request the full color brochure that I mentioned a few times with the current pricing. If you'd like to ask any questions directly, if you'd like to receive a quote for any of the models that I've discussed today, or if you would like to speak with your dedicated educational representative, you can do all of these things by calling us directly. The number here at Studica US is 888-561-7521. If you prefer to email us, you can email us at info@studica.com. Or if you have a question for me directly, based on anything that I talked about today, anything that you wish I would have mentioned, or any aspect of fischertechnik education, whether it's something that we focused on in the presentation, or perhaps any of the sets or things that we didn't discuss today, you can email me directly and I'll be happy to get back to you. I'll also get you copies of the manuals and things that I had mentioned throughout the presentation. Email me at lance.zurek, lance.zurek @studica.com. So on that note, I'd like to thank you all very much for your patience and for attending today's presentation. I look forward to hearing from you soon. Have a great afternoon and take care.